Hey guys, welcome back everyone. In the last classes, we have discussed about the split horizon rule of the IBGP, right? So in the IBGP, to disable the split horizon rule in the IBGP, we have a different mechanism. We have a full mesh and we have a route reflector, and after that we have a configuration, right? So basically what happened, whatever the issue with the full mesh, in the full mesh, what happened, you will have a lots of configuration, right? The full mesh created a lots of configuration. At the same time, what happened? It's going to increase the TCP system. So that's why what happened? We have introduced the concept of router. This was the problem in the full mesh. In the full mesh, what happened? You have to make a neighborship with the every router. You have to make the neighborship with the every router. If you have multiple bunch of the router, you need to make a neighborship with every router. In that case, what happened? You need to do lots of configuration, and at the same time, this guy is going to increase the TCP system. So if this person is going to increase the TCP system, it means that you need to require a high amount of memory and the CPU as well as, right? Because each TCP session is going to maintain the TCP block, right? And that TCP block is going to contains the information about TCP, right? The transmission control block. So to avoid this problem, what we have introduced the concept of route reflector, right? In the route reflector, what happened? Yesterday we have seen this route reflector. We can reduce the TCP system, and it's very easy to configure, right? Easy to configure. So in this route reflector, what happened? We have also seen we have two types of attributes, right? One we have a originator ID that is also going to use to prevent the loop. It's a 32-bit number. It's prevent the loop within the cluster. Right. At the same time, we have a cluster list. It's also a 32-bit number, right? And it's going to prevent the loop between the cluster. Right. So yesterday we have seen these two concepts, right? Now the question is that, right? Now the question is that to avoid the issue with the full mesh, right? To avoid the issue with the full mesh, this is the full mesh, and we have an issue with we have a lots of TCPs in the full mesh and lots of configuration. To avoid the issue with the full mesh, we have introduced the route reflector and configuration, right? My question is that if you already have a route reflector, then why we have introduced the configuration? Because route reflector is good, right? It's going to reduce the TCP session. It is going to reduce the TCP session. At the same time, what happened? We have two types of attributes that is going to prevent the loop in the route reflector, and it's easy to configure, right? Then why we have introduced the configuration? So actually, if you go back to the history, right? In a history, what happened? If I'm talking about the issue with the full mesh, so the issue with the full mesh, what happened? The engineers are some engineers are making a solution of the route reflector, and some engineers are making the solution of the configuration. And in that case, what happened? They have introduced the different RFCs over there. So they are not same RFC, right? Because bunch of engineers are there. These are the bunch of engineers. They are working on the route reflector concept, and the bunch of engineers are working on the configuration of them. So both are right on the time. On the time when this route reflector and configuration comes in the picture, on the time they don't have any ideas, right? They have a different RFCs over there. If I'm going to talk about the route reflector RFCs, the route reflector has defined in the RFC of 4456, whereas the configuration has defined in the RFC of 5065. The goal of this person, right? The goal of very simple of this person is going to remove the split horizon rule of the IBGP. The goal of this person is going to remove the split horizon rule of the RFC, sorry, IBGP. At the same time, it is going to remove the full mesh configuration as well as. So now the question is that, hey, Law, if I'm going to implement the route reflector in my network, do I need a configuration over there? No. If I'm going to implement the configuration in my network, do I need a router filter over there? No. So which one I'm going to use? If I have a production network, which one I'm going to use? Should I use the router filter, or should I, because full mesh is going to require the lots of configuration, right? It's not a good thing. If you have a like a 4 and 5 routers, you can go for the full mesh, right? You can go for the full mesh, but it's not recommendation. So if this network engineer is there, right? And if this network engineer wants to configure the IBGP in the network, and they have a almost 20 plus router, and on all this 20 plus router, they are going to implement the IBGP, right? So in which case, which solution they will prefer? Should I prefer the route reflector or configuration? Guys, it's totally depend on the requirement. If you want to apply the lots of policies over there, right? If you apply the lots of policies over there, path manipulation, filtering, right? If you do the lots of policy, that's a part of the CCI that I'm not going to discuss so much in detail. But if you do the lots of policy like a path manipulation, you know, do the community-based filtering over there, ACE path filtering, you want to do that, then you can go for the configuration. If your network is requiring this amount of policies, right, you can go for the configuration over there according to the design perspective. But if you don't have much policy in your network, right, you just need to create a simple network. You just need to create a simple IBGP network, and you don't need to require the lots of configuration. Go for the router. It's a very simple way to design. It's a very simple way. But this route reflector has some limitation. You cannot use the huge amount of policies over there as compared to the configuration. So guys, it's not like that route reflector is bad or configuration is good, or configuration is bad and route reflector is good, right? It's totally depend on the requirement. If you have a requirement of the policy, go for the configuration, right? If you don't have a much policies over there in your network, go for the route reflector. And even you can go for the full mesh as well. As if you have a 3 and 4 routers and max to max 5 router, you can go for the full mesh as well as. Right. So in the last session, right, we have done with this two part. We have covered the full mesh configuration as well as, and we have covered the route reflector as well as. Today we are going to start from the this portion, configuration. The configuration has defined in the RFC. If you just have a look over there, I can show you as well as route reflector, RFC, BGP, right? It's a 4446, right? The same RFC I have defined, right? The same RFC. And if you go for the configuration, BGP RFC is given the 5056, right? So they have a different RFCs are there. It's introduced by the different engineers out there. It's not a same, right? Now, try to understand how the configuration will work over there. Take example. All this guy is going to disable the IBGP split horizon rule, right? The goal of this person is going to disable the split horizon rule. Because there is no command in the IBGP, we need to use this features, this mechanism to disable the split horizon rule. So now try to understand one thing. The same topic yesterday we have seen that. So we have router number 1. Take example, right? We have router number 2, and we have router number 3, right? And we have router number 4 as well. So I'll do one thing. I'll put it over there, and we have router number 4 as well. All good. Now we have router number 1 that has a connectivity with router number 2, and router number 2 has a connectivity with router number 3, and router number 3 has a connectivity with the router number 4 as well. I'm saying going to take a very simple topology. I will have a next topology as well as I'll coming to this topology, but try to understand the normal way right now. So we have router number 1, we have router number 2, we have router number 3, and we have router number 4. This guy has IP addressing is 12.1. This guy's IP address 12.2. This guy's IP address 23.2. This guy's IP address 23.3. This guy's IP address 34.3. And this guy's IP address 34.4. Right? All this guy is running with the same ACE number right now. all this person is running with the same ACE number. I can say that ACE number 1, 2, 3, 4. So all this guy is running with the IBGP, internal BGP. Or we can say the IBGP. So router 1, router 2, router 3, F4 is going to run with the IBGP. Now, try to understand, we have a one network behind the R1, right? So we have a one prefix behind the R1, or we can say the NRI 100.0/8. One more thing that I'm going to introduce, IBGP does not change the next hop. Whereas EBGP does change the next hop. Right? That's the default behavior of the IBGP, and IBGP has a TTL value 255, whereas EBGP has a TTL value 1. IBGP has a AD value 200, whereas EBGP has a TTL AD value 20. This is the default behavior, right? Now try to understand one thing. By default, split horizon rule is enabled, right? By default, split horizon rule is enabled. So when R1 will send the update packet to the R2, right? When R1 will send the update packet to the R2, so in this case, what happened? They'll put this information in the BGP update packet, right? 100.0/8 information. And why I'm going to put the submit mask information? Because this is my classless routing protocol. BGP version 4 is my classless routing protocol, whereas the BGP version 1, 2, and 3, it was all a classful. And we are not using this thing, and you cannot change the version as well as. We are not using this thing, and you cannot change the version. By default, BGP version 4 is enabled. And the BGP version 4 is the classless, so submit mask information is there. The submit mask information in the update packet is just going to represent that it's a classless routing protocol. So now try to understand what happened when R2 will receive this update. When R2 will receive the update, what happened? R2 cannot share same update to the R3 by default because of the IBGP split horizon rule. The IBGP split horizon rule say that whenever the BGP router, right? This is the guy is saying that whenever the BGP router receive the update from IBGP neighbor, right? So this is the IBGP neighbor for R2. So whenever the BGP router receives the update from IBGP neighbor, it cannot send the same update to the another IBGP. It cannot send the same update to the another IBGP. But if you have a EBGP, it can send the update to the this person, AS number 4. Router number 5 is number 4. It can send the update to the EBGP, but it cannot send the update to the another IBGP neighbor. So to avoid this problem, what we can do over there, I can implement the configuration. So how the configuration is going to work over there? What configuration is going to do? I'll tell you this configuration. Configuration is just going to break, right? It's break public ACE into private. In a simple way, we can say that it's just going to breaking the ACE number. In a simple way, it's going to say that it's just ACE number. In a simple language. So what happened? I'm just going to divide this topology, right? I'm just going to divide this autonomous system. So right now, whatever the private ACE number we have, the range of we have. So basically the ACE number range. ACE number is a 32-bit number, not 32-bit. Right now we have a 16-bit number. We have a 32-bit as well as, right? I'll show you that we'll discuss in the 4-byte in the next lecture. So ACE number is a 16-bit number. In this 16-bit number, what happened? We have a 0 is reserved, right? Then after that, we have a 1, 2, 6, 4, 4, 9, 5. This guy is going to represent as a public ACE number, right? Then after that, we have a 6, 4, 5, 1, 2, 2, 6, 5, 5, 3, 4. This guy is going to represent that it's a private ACE number. In between, whatever the ACE remaining is there, we have a 6, 4, 4, 9, 6, right? 2, 6, 511, right? That's going to reverse for the documentation. And the last one we have a 65535. That is also reserved. So basically we have a range of this one. The ACE number has a range. So we have a publication number. This one is the publication number, right? From 12645 and we have a private ACE number range this guy. So we can write down over there, right? So we have a range over there, 6451264 495 is a public. In the publication number, what happened? You need to pay some amount of money to the ISP, right? It's not a free, you have to pay. Publication number, you have to pay to the ISP. Right? At the same time, we have a private ACE number. That is 64512 65534. That's a private. Now try to understand what I'm going to do right now. Right now, this is my ACE number 1234, right? This is my publication number, right? This is my publication number. So what I'm going to do, I'm just going to divide. How? Right now, R1 can send the update to the R2, but R2 cannot send the update to the R3, right? That's the default behavior because of the IBGP split horizon rule. Can I say like this? I'm just going to divide this portion now in the 1 ACE number, right? And I'm going to divide this portion now into, into the another ACE number. It's fine now. So mic is on, can you receive your mic? Now basically what happened, this is my, right now, this is my parent ACE. We can see that, right? This is my parent ACE. And this parent ACE has a 2 child, right? So this is my parent ACE. And this parent ACE has a 2 child 1. And this is a child 2. So this ACE number, I'm just going to break this public ACE number into the private ACE number. So I can see that I'm going to assign this private ACE number to this guy because the private is free, right? The private ACE is a free. So I can say that, okay, you can use the 64512 and you can use the 64513. So try to understand, it was a IBGP, right? It was IBGP. Now what happened? We have a EBGP. Between the R2 and R3, we have EBGP. So now do we have any issue with the EBGP? No, we don't have any issue with the EBGP. EBGP can say the information, right? So now what happened? In this case, we have disabled the split horizon rule. So now when R1 will send the update to the R2, R2 will propagate this information to the R3. Why? Because the behavior of IBGP split horizon rule, whenever the BGP router receive the update from IBGP neighbor. So this is the IBGP neighbor, right? This is the IBGP neighbor. It cannot share the update to the another IBGP. But right now, what happened? This is the EBGP. Can you see like this? This is the EBGP, right? So R2 can share the update to the R3, and now R3 can share the update to the R4. So now this information will be flooded to the this guy. And this guy's answer. So now this information, R2 will also have this information, R3 will also have this information, and R4 also have this information. Now we can communicate to each other. So this parent ACE, or we can say this public ACE, is going to break with the 2 private ACE number. So internally, right, this ISP service, so this is the service provider, right? this service provider or because ISP network, right? What happened? ISP is going to break the public ACE number into the private ACE number, child one, child two. So this is the parent ACE number. So what customer, does customer have any idea? This is the customer over there, right? This is the customer, this is the customer. This customer does not have any idea about the configuration in the ISP network. They don't have any idea because this private ACE number is not exchanged with the true eBGP number. This right now, what happened? This is the eBGP, right? This eBGP is not a true eBGP. It's a configuration eBGP. It's not a true EB. It's not a pure eBGP. What is the meaning of pure eBGP? The pure eBGP is saying that R1 and R2 has a two different ACE number, ACE number 1 and ACE number 2. It's a pure eBGP, but it's a configuration eBGP. We have a private, we have a public ACE number, internal BGP session, right? Over this internal BGP session, what happened? I just divide this guy into the two private ACE number to just disable the split horizon rule behavior, so that they can exchange the update from R1 to R2, R2 to R3, and R3 to R4. In a route reflector, what happened? We are making a one router as a server, right? In the full mesh, what happened? We are making we are configuration neighborship with every router to every router. But in a configuration, what happened? We are just going to divide the ACE number. Well, I'm going to make a parent ACE, that's my public ACE number, and I'm going to make a child one, child two. That should be a private ACE number. Now, why I'm going to use the private ACE number in this section? Because private ACE number is a free to use, like a public private IP address, like a private. It's a free to use. You can use public ACE number as well as over there, but it's not recommendation. Never recommendation to use the public ACE number. You have to pay some amount of money over there. Private ACE is a free. You can use it. So we can say that this guy is known as a configuration IBGP, right? This guy is known as a configuration IBGP because R3 and R4 are present in the same ACE number. Can we have a look at the same ACE number is there? The same ACE number is present, right? R3 and R4 is same ACE number. R1 and R2 is the same ACE number 64512, but between the R2 and R3, we have a configuration eBGP because this guy has R2 is running with the 64512 and R3 is running with the 64513. It's a configuration eBGP. But actually, in a reality, what happened? In a reality, this guy is participating into the ACE number 1234. This is the reality. The reality is like, okay, something is break. 1 minute. Now, this is now reality. This guy. In reality, what happened? All this router number 1, 2, 3, 4, they belong to the ACE number 1, 2, 3, 4. But by making a configuration, what happened? I'm just dividing this guy into the two different ACE numbers so that they can exchange the update. Because IBGP is saying that I can only send the update to my neighbor. R2 cannot send this update to the another IBGP, right? That's the problem is happening. So that's why we make a different, we make a configuration over there. Let's see the configuration point. So we have some topology over there, right? I'll show you the first pre-configuration over there. So by default, split horizon rule is enabled, right? So we have a router number 6. We can say the customer 1. We have a customer number 2, router number 7. This guy is going to use the public ACE number 6 over there. And this guy is going to use the ACE number 7. We have a one route over there, public route. And we have a customer route over there, right? As well as, so these are my customer 1. And we have a customer number 2, right? And this is my ISP, service provider networks, internet service provider. And this guy is going to use the public ACE number. ACE number 1 is a public ACE number. And you can see that I have used the 3 different private ACE numbers: 64512, 64513, and 64512. Sorry, 514. So now try to understand. First, I'm going to configure the ISP network, right? I'm just going to configure the configuration part. Then I'm coming to the customer as well as. So first, also you the whatever the pre-configuration we have. Let me remove this guy. But again, I'm repeating, guys. Route reflector and configuration has defined the different RFCs, right? So depend on the requirement, you are going to use the different. If you have lots of policy, you can go for the configuration, and if you don't have much policy, you can go for the route reflector, because route reflector is easy to configure as compared to the configuration, right? But configuration is also not hard; it's easy. So if you see on router number one, I'm present right now, and if you first verify the show IP interface brief, exclude unassign, all good. We have a good to go IP addressing. Somebody is not there, I don't have any protocol. I'm going to enable the router EHRP to just exchange this information, right? This information, because IBGP does not change the next hop, right? So I'm just going to make this guy reachability, so that because whenever the BGP router receive update, it check the next hop reachability. If the next hop is not reachable, the router BGP router never marks that route as a best route. It's just a valid route. And if the route is not best, router is not going to install in the routing table, because routing table always maintain the best path. So to just make a next hop reachability, right? We are going to advertise this WAN in this connection, right? Router number two, please verify the first config swipe interface brief. All good to go. Router EHRP number one, network 12.0, and I can configure 0.0, right? Right? Do show IP protocol summary. Only EHRP is there. That's good. I'm not enable the BGP right now. Do show IP interface brief. All good. Router EHRP number one, network. All good. BGP is not there. Perfect. R4. Show IP interface brief. Good to go. And router EHRP number one. I'm just going to advertise my WAN interface, right? Just make a utility this WAN interface, right? This physical interface to just make a next hop utility. That's it, nothing else. R5. Now on R5, what I can do, I'm just going to do show IP interface brief first of all, right? So 45.5 this guys have. So if this guy does not have IP addressing, let's configure 0/1. It should be 57.5. Okay, not 5. It should, yes, it's 5. Again, those WRs in this configuration, right? And router EHRP number one, network, I'm going to advertise this network 45.0. All done, right? Let's start the BGP now from R1. So now R1, what I'm going to do, guys? Which ACE number I'm going to use? Should I use if I'm going to start my configuration, I need to put the command router BGP, right? Which ACE number I'm going to define? Should I define the public ACE number, or should I define the private ACE number over there? Here, I'm going to define the private ACE. I know this guys belong to the public ACE, right? Because this is the father, we can say that, right? This is the father, and they have three sons, son one, child one, we can say that child two, and child three. So I'm going to say that, hey, you are going to use this ACE number. The router number one is going to use the 64512 ACE number, right? All good. And now what I'm going to tell this guy, hey, my father is ACE number. My father is ACE number, BGP configuration identifier. This ACE number, the private ACE number, is the participating in the ACE number one. This is the public ACE number. So my configuration identifier, that's the configuration. This is the configuration that I'm going to run over there. I need to make an identifier of this domain, right? That's the configuration identifier. So I'm the son and my father is the one, right? Now I'm going to say a neighbor. I'm going to form the neighborship with the home 12 or 2. And that has a remote ACE number, will be same ACE number 64512, right? Go back to the router number 2. On a router number 2, what happened? I need to tell this person, router BGP, 64512, right? As a neighbor, 12.1, remote edge will be 64512. Just wait for some time. Can you see that I have a neighborship? I have a neighborship. So maybe you have a question. No, you have defined the identifier on the router number 1. You have defined the identifier on the router number 1, but you didn't define on the router number 2. Why? Hey guys, try to understand. Even if I'm going to remove this command right now, they still form the neighborship. There's no issue with the neighborship. There's no issue with the neighborship, right? Try to understand this configuration. If I'm going to remove this command, there's no issue with the neighborship. But the thing is that when this customer, right, router number 6, right, when the router number 6, if you see show IP interface brief, I have IP addressing over there. So I said router BGP number, my AS number is 6, right? This is my publication was 6 over there. I'm going to form the neighborship with the whom 16.1, right? What remote edge I'm going to do at over there? Should I put the remote edge 64512 or should I put the remote edge AS number 1? On a router number 6, my AS number is 6 over there. In the remote edge, what should I put? Should I put the remote edge 64512 or should I put the remote edge AS number 1 over there? I need to put the AS number 1. Why? Because this is the publication number. Private AS number is not routable. Private AS number is not routable like a private IP addressing. Like a private IP addressing, private AS number is not routable. This private AS, and this private AS is never advertised. It's never ever advertised to the customer. Never ever. I'll show you this thing as well as don't worry. This guy, this customer, right? This customer is only have an idea of the publication number. So I need to put this command on the router number 1, AS number 1. On the router number 6, right? On the customer side. And on the router number 1, I need to define this guy neighborship 16.6. And I said the remote AS will be 6 over there. And now see the problem what happened. I have removed the configuration, no configuration BGP identifier, right now. And try to see the problems. They will not form the neighborship. Never ever. Why? I'll show you. Can I ping this guy? My URL is there, right? I hope. 16.1. Okay, something is missing. You swipe interface brief. That's why some message is not happening. Wait. 0/1 is not given. Right. So let's define this guy. So IP address was not configured, right? That's why. Can you see what happened? Why this thing is happening? Because when router number one is sending the update packet, right? So not update packet, open packet. In this open packet, what AS number they are sending over there? If you just capture this link, can you see the router number 1? That's a 16.6, right? The router, this is the 16.6 one, is sending which AS number? 64512. Router 1, right? Router 1 is saying that, hey, my AS number is what? My AS number is 64512, right? And what configuration I did on a router number 6? On a router number 6, I did the configuration router BGP 6. I said the neighbor 16.1 AS number will be 1. So on the router number 6, you define the route AS number 1. But on a router number 1, he sent the open message with the 64500. Is it matching? No. Pair in wrong AS. Notification packet will be generated, right? A notification message will generate. If you see right now, he's sending a 64500. This is 16.1, right? That is this guy, 16.1, this guy, R1. Sending the packet to the R6, right? With the 64512. But actually, router number 6 is configured with the what? Is number 1, right? It's not matching, right? So I will generate a message, hey, wrong age. Notification message will generate, so wrong age. So what happened? To avoid this thing, what I have to tell this guy, hey, router 1, router BGP 64512, who's my father? My father is a 1. This is the requirement of this command. And that's why this command I didn't configure on R2. This is the reason why I have configured this command on R. Now, if you see the open message, in the open message, what happened? We capture this link 16.1. So previous, now new, after putting this command line. So 64512, now we change with the. So now the data is matching, right? So if you see, so previously it was sending the my age number is 64512, and this guy has configured with the remote age will be 1. So it's not matching, right? Now it's sending the age number 1. It's matching, right? Go to go. Good to go, right? I can have a new ship now. So that's why this command is requirement on the router number 2 to just let them R6. Hey, dude, I'm running with the is number 1. That's my private is, right? I'm running with the configuration, right? I'm running with the configuration. So in the open message, I'm going to send this is number, not the this is number. So I need to configure this configuration identifier only on the edge router. On an R2, if you see, I've done with the R2 now configuration now. Now go back to the R2 to R3, 23.3, right? I'm going to form the name of this guy, and this guy is going to run with the 6451. Remote age will be 6451. On R3, router BGP number 64514. Neighborship I'm going to form with the 23 or 2 that has a remote age will be 64512. Same thing, router number 3, 34.4. Remote age will be what? It's going to have a 64513, right? 64513, and router number 4, neighborship is what? 34.3, right? Remote age will be 64514, right? Same thing, I need to do this guy as well as 6445.5, 64513, and router BGP number 64513. BGP configuration identifier because it's an edge router, so I need to say that this guy, and I need to put this guy as 45.4, 6451. Now try to understand one thing. This command is clear, right? The BGP configuration identifier. This command is just going to tell this router number 1, hey, I'm the part of the publication number 1, right? Now, what I told you that this is my father, right? And these are my son 1, son 2, and son 3. So basically what happened, R2 and R3 is behave like what? Brother, these are the father is same, right? Son 1 and son 2, they are the same father, right? His father is father is A, his father is also A, his father is also A. This is son, brother, right? We can see the pair in the BGP terms. R3 and R4 also appear. So what we have to tell this person, right? Router number 2, here router number 2, my BGP configuration pair is what? 6451. On router number 3, I need to say that this guy BGP configuration pair, my pair is what? 64512, and my BGP pair is 64513. Same thing, I need to go on router number 4, BGP configuration pair is what? My pair is good to go now. So now the same thing, I need to go on the router numbers 5 as well as this guy, right? Router number 5, I need to make a neighborship with this person as well, right? So I need to go on the router number 5, I need to say the neighborship, I'm going to form with the 57.7 that has a remote age will be 7 over there. All good. And I need to go on the router number 7, check the IP addressing, so IP interface brief, and I just router BGP number 7. Neighborship, I'm going to form with the 57.5. Remote age will be age number 1, right? So already have defined the router number 5 the configuration identifier, so no need to do anything, right? So they will form the neighborship. All good. Now, if you see one thing, what I can do on a router number 6, right? If I'm going to advertise this LAN information, right? This network I'm going to advertise 6.0.0.0.0.0. What happened? R6 will send this update to whom? R1, right? In this one, what happened? They will add the own age number. This guy is going to prepend the own age number. So he's going to say age number 6, right? So this is the ABGP connection over there. But when R1 will send the update to the R2, what happened? We have a 6.0.0.0.0. What will be the next hop in this case? The next hop will be 16.6 still, right? In the R2 table, right? If you just go back to the router, I have advertised route, network 6.0.0. And if you just have a look, do so IP BGP, what happened? This route is a valid and best, right? And the next hop 0.0, the next hop 0.0 is just going to represent that it's a locally originated route. It's a locally originated route. This route is advertised by the local to the router number 6. That's the meaning of next hop 0.0. So if you go back to the router number 1 now, I'm able to receive this update, right? Do so IP BGP. I got the update, right? From the next hop 16.6, right? When R1 is going to send this update to the R2, do you know what will be the next hop? Still 16.6. Why? Because iBGP does not modify the next hop, that we know, right? iBGP does not modify the next hop. So in the R2 routing table 6.0.0, we have a 16.6. So next hop is not reachable. So if the next hop is not reachable, what happened? This route is just a valid route. It's not a best. So if the route is not best, can I install this route in my routing table over there? No. Next hop is not reachable. I cannot ping this guy. Can you have a look over there? I cannot ping. So what I can do on a router number 1, what I can do on a router number 1, I say that, hey, router number 1, whenever you're going to send the update, right? And see the router number 1, hey, router 1, whenever you're going to send the update to whom, 12 or 2, whenever I'm saying informing router number 1, whenever you're sending the update to the router number 2, right? 12 or 2, please change the next hop. I'm informing, right? I mean, by default, the R1 is not changing the next hop because it's IBGP, right? So I'm just informing, I'm forcefully saying, please change the next hop, right? So whenever the router one will send the update to the 2L2, he's going to say the next hop self. Self means what? I'm going to put my own next hop. Instead of this guy, I'm going to put this next hop now. So if you see for this update, 6.0.0, what next hop I'm going to use now? 12.1, right? So this is the older output. The new output will be on R2. We have a 6.0.0.0.0.0. Next hop will be 12.1. So can I ping from the 12.1 from R2? Yes, of course we can ping it. Now if you see the do show IPVGP, the previous information 16.6, route was not best, it's best. Because from R2 I can ping this guy 12.1 right easily. So now if you go back to the R3, now R2 can save this information to R3 because now it's an eBGP connection, right? It's a confidential eBGP. So if you see do show IPVGP, can we see? If you go back to the router number 4 as well as router number 5, then router number 6, that's another customer, right? I mean, not 7, do show IBGP. Okay, 1 minute. This A should be not there. 1 minute. Something I made a mistake somewhere. I did the mistake. Okay, my peer is this guy. Okay, my peer is this guy, and R4. My peer is this guy on R3. My peer is 64512 and 6. I didn't inform this guy, right? Router BGP 64512. I'm the member of this person, not the different one. I need to inform this person as well as now make it clear IPVGP hard. This output should not be there already. On the customer side, this output should not. Only they say it's not the publication, not the private. Okay, 1 minute. Was it was 6 yeah 6. 1 minute. Some time. So now hope they will receive now. I'm still getting the 64512. 64511 not getting. Still missing over there. I did it right. Which router I'm missing the configuration identifier now. R3 I've done right configuration identifier. R4 let's have a look over there. Show IPGP 64512 64. Yes, it's giving in the bracket, right? It has to be in the configuration always in the bracket. Okay. I did it in form this as well as now hope I can get the output. 1 minute. To clear IPGP hard. Now come back to the point. I hope I can get this information right. because that's this guy was making a neighborship with this person, right? He's not aware with the member of this confederation peer, right? Um, it's a bit of slow routing protocol, so you just need to have patience, right? Good to go. Can we have a look over now? So now this private at the private ACH number is not routable. Can you see that? We always have all this information. But in the, within the configuration, right? Within the configuration, if you have a look on the router number 5, we can get this information. This route is coming from home. This route is coming from this guy 64514 and 64512. That's a configuration ACE number. But actually, the origin of this route is from the ACE number 6. That's a publication of this guy, right? I'm posting on R5 right now. On the R5, I'm just checking this database information, right? So on a R6, or when R5 is going to share this information, so on a R5, the update is something like this. We have a on R5 BGP table, we have this guy 106.0.0.0.0. We have a 64514, 6451. It should be 2. It should be 4 now, and should be in the bracket because this is a configuration identity. This is a configuration age number. Then we have a age number 6. But when R5 is sending this update to the R7, how they are sending this guy sending the update 6.0.0.0.0.0 ace number 1, that is this guy publication one, that and 6. So it's not the R5 is not going to share the this configuration identity, this configuration ace number, because this is a private, right? Private cannot share with the customer. So this is how we are extending this. The update is coming from this side is like how he's sending the update with the 6.0.0.0.0.0 with the ace number what with the ace number 6, right? When R1 will send the update to the R2, when R1 will send the update to the R2, how they R1 will send the update to the R2, it will just send the ACE number 6 because IBGP does not contain the ACE path information. IBGP is there, right? But when R2 will send the update to the R3, on R3 we have a 6.0.0.0.0.0, right? With the ACE number 64512, right? And then ACE number 1, sorry, ACE number 6, that is this guy. But when R3 will send this update to the R4, on R4 we have look like this 6.0.0.0.0. Now the R3 is going to prepend the own H number. So he's going to say that, hey, let's make it 64514, 64, then 64512, and then H number 6, right? So same information on R5 we have, right? 64514 and 64512. When R4 is going to send this update to the R5, right? And R5 has the same database table, right? 64512. Okay, so 64512. It's prepending, right? So it's 64512 and 64512. And when R5 will send the update to the R7, it's just going to send this update. It's not going to send the customer, right? Customer, this private H number not routable. So customer does not have any idea. Customer does not have any idea about this ISP is implementing the configuration or not. This is how the configuration is working, guys. And from this side, if you see router number 7, if you go to router number 7, so I'm going to advertise this guy, right? So again, R7 will send this update to the home R5. R5 will send this update to the R4, right? So in the R4 BGP table, what happened? You will have a next hop information. What in the R5 BGP table, right? You have a next hop this guy, right? 57.7 still, because IBGP does not modify the next hop. So again, reachability is not there. Okay. Did I advertise any route over there? This one, do show on section in GRP. Okay. Okay, I need to check on router now 4. Okay, fine. So now R4, if you see, this route is again not a best route. Why? Because I cannot ping this person, right? I cannot ping this person from R4. We don't have a reachability. So what we have to do on R5, I can also change the next hop from this side. I say that 64513 64513. Whenever you're sending the update to the home 45.4, please change the next hop. R4, I'm going to inform R5. Hey, whenever you're sending the update to this guy, please change the next hop own self. So now if you see on R4, previously it was not changing the next hop. Now it's changing, right? 45.5. Now this route is a valid and best. Now R4 can say this is R3, R2, and R1. So if you see on R6, we got the information, right? Okay, 64513 is coming. So I think so I'm missing something. On R4, I mean different this one. Out of BGP 64513, BGP configuration identifier will be 1. Good to go. Then wait for some time. This will reboot. Wait for some time, right? This 0.0 means what? It's a locally originated route. Come on. Get up, man. R4, membership is coming up. It takes some time. It's slow routing protocol, right? So just have some patience, right? Whenever you're doing the configuration on the BGP, just have patience. Okay. So I'll tell you what I configuration. So on this router number 2, I'm just going to make a peer of this person, right? Configuration BGP peer. I'm going to make this guy, right? This person, right? Configuration BGP peer. So I'm going to inform the R2 and R3, hey, we are the brothers, right? And R3 is also going to inform to the R4, hey, we are the brothers. So R3 is going to inform this person, hey, we are the brothers, right? We are the brothers, right? At the same time, what happened on a router number 1, a router number 2, router number 3, 4, and 5? I need to inform, hey, we are the member of same configuration. That should be a configuration identifier will be 1. If you're not going to put this configuration identifier 1 on a router number 2, then in that case, what happened? The edge router is going to advertise the private edge number as well. That's not recommendation, right? If you don't configure this thing, it form the neighborship 100%. There's no issue with the neighborship, but still, what happened? You will get the this information. If you don't define the identifier, you will get this information. That's not a good thing, right? So that's why we need to tell this person that, hey, my identifier is a 1. So now hope I will get this information. All good. So this is how, guys, we can exchange the age number. We can implement the configuration over there, and we can exchange the customer to customer routes over there. And this is how the ISP is going to travel the update. So it never shared, right? ISP never share the private age to the customer, never ever. And the customer does not have an idea about the configuration that ISP is implementing the configuration or router and they don't have any idea. So this AS number, sometimes if you see this AS number, right, it's this AS number is also known as a compt AS, compt AS as well as, right? Now, if you see in the wire track, you will get the configuration of it. I'll show you this thing, and I will advertise one update from router 6. I'm going to create a one loop back. Okay, come on. I said that AS 6. Update passes, right? And RI 60.0 path attributes. If you see, we have a configuration. Is path information. Yep. Count sequence is right. This is the AS1. See you if you come to 64512, 64512. Right, guys. Hope this thing is clear to all of you. And if you have any questions, we can ask me now. I'm done.